Welcome to Site Reliability Engineering Crashcasts. I'm your host, Sheila, and today we're diving into the world of configuration management with a focus on Chef. Joining me is our expert, Victor. Before we begin, listeners should have a basic understanding of IT infrastructure and automation concepts. Today, we'll cover Chef's role in configuration management, its key components, and how it compares to other tools in the field. But first, let's start with a quiz question. What is configuration drift, and why is it a significant concern for SREs?
That's an excellent question, Sheila. Configuration drift is indeed a crucial concept for our listeners to understand. Without giving away the answer, I'd say it's something that keeps many SREs up at night. It's closely related to the stability and consistency of our systems, and it's one of the main reasons why tools like Chef exist. I'm curious to see how our listeners will approach this question.
Great point, Victor. Now, before we delve deeper into Chef, could you give us a quick overview of configuration management and why it's important for SREs?
Certainly, Sheila. Configuration management is the practice of maintaining systems, servers, and software in a desired, consistent state. It's crucial for SREs because it helps ensure that our infrastructure is reliable, scalable, and easily reproducible. This is where tools like Chef come in, allowing us to automate the process of configuring and maintaining our systems.
That makes sense. So how does Chef fit into this picture? What role does it play in configuration management?
Chef is a powerful configuration management tool that follows the principle of infrastructure as code, or IAC. It allows SREs to define their infrastructure using code, specifically Ruby-based DSL, which stands for Domain-Specific Language. Chef uses a client-server architecture, where the Chef server acts as a central hub for configuration data, and Chef clients, called nodes, pull and apply these configurations.
Interesting. Can you break down the main components of Chef for us?
Certainly. Chef has three main components. 1. Chef server. This is the central hub that stores configuration data, cookbooks, and information about the nodes. 2. Chef workstation. This is where SREs create and test their cookbooks before uploading them to the server. 3. Chef nodes. These are the machines that are managed by Chef. They can be physical machines or virtual ones. Chef uses cookbooks and recipes to define how to configure systems. A cookbook is a collection of configuration instructions, while recipes are specific sets of instructions within a cookbook.
That's a helpful breakdown. I've heard the term idempotency used in relation to Chef. What does that mean and why is it important?
Great question, Sheila. Idempotency is a key concept in configuration management. It means that applying the same operation multiple times produces the same result as applying it once. In the context of Chef, it ensures that running a recipe multiple times on a node will always result in the same desired state, regardless of the node's initial state. This is crucial for maintaining consistency and predictability in our infrastructure.
That makes sense. Now, let's talk about how Chef compares to other tools in the infrastructure automation landscape. What are some alternatives, and how do they differ from Chef?
Chef has several competitors in the configuration management space, including Puppet, Ansible, and to some extent Terraform. Let's compare them briefly. 1. Puppet. Like Chef, Puppet uses a client-server model and its own DSL. However, Puppet uses a pull-based approach by default, while Chef uses a push-based approach. 2. Ansible. Ansible is known for its simplicity and agentless architecture. It uses YML, a human-readable data serialization format, for configuration files, making it easier to read and write compared to Chef's Ruby-based DSL. 3. Terraform. While primarily an infrastructure provisioning tool, Terraform overlaps with Chef in some areas. It's declarative and focuses on describing the desired end state of the infrastructure. Chef's strength lies in its flexibility and powerful DSL, but it has a steeper learning curve compared to some alternatives.
That's a helpful comparison. Are there any common pitfalls or best practices that SREs should be aware of when using Chef?
Absolutely, Sheila. Here are a few key points. 1. Version control. Always use version control for your cookbooks. This allows for easy rollbacks and collaboration. 2. Test-driven development. Use Chef's built-in testing frameworks like ChefSpec and InSpec to ensure your cookbooks work as expected. ChefSpec is for unit testing recipes, while InSpec is for testing the actual state of your infrastructure. 3. Avoid snowflake servers. Resist the temptation to make manual changes to servers. Always make changes through Chef to maintain consistency. 4. Use roles and environments. These Chef features help organize your infrastructure and make it more manageable. 5. Keep it simple. Start with simple recipes and gradually increase complexity. Overly complex cookbooks can be hard to maintain.
Those are great tips, Victor. Before we wrap up, do you have any interesting facts or anecdotes about Chef?
Sure. Here's a fun fact. Chef's creators named many of its components after cooking terms to make it more relatable and memorable. For example, cookbooks, recipes, and even the name Chef itself. This culinary theme extends to their error messages, which often include food puns.
That's delightful. Now let's reveal the answer to our quiz question. Configuration drift occurs when the actual state of a system deviates from its desired or declared state. It's a significant concern for SREs because it can lead to inconsistencies, unpredictable behavior, and potential failures in the infrastructure. Tools like Chef help prevent configuration drift by continuously enforcing the desired state.
Excellent explanation, Sheila. To help our listeners remember this, they can think of configuration drift like a restaurant kitchen slowly getting disorganized over time. Chef, true to its name, helps keep everything in order.
That's a great analogy, Victor. To summarize today's episode, 1. Chef is a powerful configuration management tool that uses infrastructure as code. 2. It consists of a server, workstation, and nodes using cookbooks and recipes to define configurations. 3. Chef ensures idempotency, making it reliable for maintaining consistent infrastructure. 4. While Chef has a steeper learning curve, it offers great flexibility compared to alternatives like Puppet and Ansible. 5. Best practices include version control, testing, and avoiding manual changes to servers. Thanks for tuning in to Site Reliability Engineering Crashcasts. If you found this episode helpful, please subscribe and rate our podcast. Until next time, keep your infrastructure as organized as a well-run kitchen.